Well, hey YouTube, it's Petey Two Finger, and this is part 2 of a video where we're talking about the test-a-matron 7800. This is a little, you put your iPod up here and then run a cable down. It's an amplified speaker. I put a test signal generator, so you could, if you built a guitar pedal circuit and you're in that stage where you just finished it and you need to test it out, this is what you would use. You wouldn't use a guitar, because if there's a problem and you're going to need to spend some time servicing this, the idea of having a guitar that you're going to have to keep playing that all the time is not a good idea. So this has all the everything you need. There's a power supply. This signal output is a beep that connects up here on the input of your circuit, and then the output here goes into the amp, bypassing this. So how did we make it? Well, the first thing we did was take the screws out and get at we removed this so we could get this out. So we had the PCB out. So then I plugged a jack in here. This is cut. And I used a cont test, deep cont. I was just talking about this the other day. And what we did, we would go here and go onto our wire and then go on the board and start poking around. Oh, here we are. So then I knew that the ground for this input is the same as the battery ground. It's just universal ground is ground is ground. And then for the input, we went ahead and poked around until we found there. And when we got that to beep, I went ahead and I used a red Sharpie and I marked it. Now typically when you find the input, when you're looking for the input on a jack, it'll be... There's a jack that's soldered in, and there'll be like 2 or 3 pins for that jack. So you just look right there and start there. And maybe you'll hit this one. And it's at the front of the jack. That's going to be the ground. But the furthest point is going to be this tip connector here. And that's what we were looking for. We were looking for the hot side or the input. So when I went looking at it, where the jack is on the other side of the board where the solder points are, it would be the third one. So you have ground, right channel, and left is all the way in the back. Or is it left and right? I don't know. Point is, when we found it, we marked it with a Sharpie. And then the other thing was finding power. I wanted to use this battery pack, which is 6 volts, it's not 9, to power both the amplifier and the signal generator, the tone. Test tone oscillator. So we did the same thing. We hooked up one end of our beep cont test to the ground, and then okay, there's the ground, and we marked that with a black Sharpie. And then our positive, we went and turned the power switch on, and then we hit this and found there it is. And it beeped out. So when we mark that with a red, where the spot on the switch where the power comes in, and there's another spot where there's a switch. So, I mean, ideally, when you do that test, when you determine that spot, you want to shut it off and test it again, and you shouldn't get a beep. You should only get the beep when the switch is on. Then you know, okay, you're going to be able to get 6 volts from positive 6 volts from that spot on the circuit that you marked red that came through beep beep when you were touching on the red battery pack when the switch was on. When you shut it off, it should not beep. Then you know. Now another way to do that would be to go right on the switch. You could test this on the switch and see which side of the switch is coming in and which is coming out, and tack your wire on to the output. But the idea was for me to be able to get 6 volts to power the oscillator circuit, and to get the input for the amp. The other way I could have done this was I could have taken this connector here and soldered in these wires onto this. And then you would have plugged this in here and had it coming off of the front. I didn't like that idea. I like the idea of having it on the side. For one, I don't know. This is cool. It plugs in the side. Ye old input. And there you go. It plugs in the side, and that's the way we went. So it was another hassle of drilling this out, installing this and running a pair of wires up to that point. But was it a hassle? Not really. This was a really fun little project, and I'm glad we did it. It's going to come in handy. I'm going to use this all the time. When this battery drains, we can just pop it out, unplug this connector here, pull this off of here, remove the dum-dum, pop a new battery in, and ideally I'll keep this here clipped on just to keep it from shorting itself. And if we want to take a look at the Vero layout real quick, there's some stuff I wanted to address. It's called the audio oscillator, and it runs off of 9 volts. It uses a pair of 2N3904 transistors, which are real common. You used to be able to get those at Radio Shack. And then 1N914 diodes, which those are actually 1N4148. It's the same thing. 1N914 is the old name for those. So looking at it, well, ours isn't 9 volts and it's 6 volts. So I thought, gee, look at R5. We have the power coming in at the top right rail, 9 volts, and then going through R5. And R5 is a 4.7K. So I thought, well, okay, we're using 6 volts instead of 9. Maybe I should lower the value of that resistor. So I installed a pair of sockets on the 11th row in place of R5, and then I tried a lower value resistor. And sure enough, it worked. So it has a 3.6K resistor. We also put sockets in for Q1 and Q2 because they're bulk transistors, and I just always like to put sockets in my transistor in case the pinout's different. I mean, if you solder in the transistor and the pinout is wrong, it's a little bit more messy unsoldering it. If you have a socket, you can just pop it out. So it was an easy project with 8 cuts, 3 jumpers, a 13x7 Vero. I used a it was like a 23x7. And I'm glad that we had a wider Vero. The reason I went with the wide Vero was because that's what I had. I had a cutoff that was 7 down, and I just left it long because if you look over here, I have a adhesive pad, a double-sided tape here, and it just fit really well. You know, I'm sure I could have cut this here and I could have put the pad here, but I think it adheres a little better in this way without all the bumpy solders. And it was mainly just because I had a piece that was that wide that I did it. I didn't feel like cutting it. So the other thing that I should mention is we used a, this is the little lid. We used a trimmer pot instead of a full-size potentiometer. It calls for a 10K pot for the, you know what, I'm going to get rid of this thing. This is the top shelf. Well, normally there's a little shelf for that MP3 thing. I'm going to throw it away. So it calls for a pot for the volume on this, and I did not want to have another volume. I thought, let's install a trimmer. That way I can just adjust it to what I want once and leave it there. So the board is like this long, and there's one last row for you to hook up 3 wires to come out to this pot. And the trimmer is like a triangle. It's like 1, 2, and then 3 is over here. So you need a little longer. So if you're going to make this and you like the idea of having an onboard trimmer that you would just adjust once and set and forget it, I would recommend go ahead and do that. But with the stock layout being just 13 wide, it's not enough. You're going to need to make it 14 or 15 wide. Ours was already really wide, but basically the way that they had made it was with the volume 1, 2, and 3 right in a row, and that lined up perfectly with my set and forget potentiometer. So yeah, check out the beefy speaker, the big magnet in there. It's a pretty good size speaker, although the amp isn't really very impressive. It does have a heat sink on the amp. You can see here. Here's a heat sink. And it's a quality little device. I was really impressed with the performance of this. It's going to, as I said, it's going to be a test rig, a complete all-in-one test rig with a little power supply. It's got a little extra 9-volt battery, and I'll go ahead and connect it to itself, although in all reality, it's going to be going. That's the bass knob. The treble doesn't do much, but like I said, this tone is more of just a notch. It's not. So yeah, this is a piece of test equipment. How it will be implemented is you finish your fuzz circuit or whatever guitar pedal you built, and all of them have 3 things in common, which would be they need 9 volts coming in, they have an input and an output. So I got you covered. Here's the 9 volts. Here's the input connector, which sends the beep coming in, and here's the output going into the amp. So please don't be under the guise or the opinion that I'm trying to say this is the tone is in your fingers and it's in the test-a-matron 7800. This is my answer to tube glory. No, this is a piece of test equipment. I wouldn't really even be playing much guitar through it. I'm sure I will. I'm sure I'll, rather than get the long cables that have been adapted to alligator clips and hook up a nice amp and a guitar, I'll just get one of these, hook it up, and play through the test-a-matron 7800. I'm sure I will be playing through this, especially with the bass and the treble control. But am I going to make a habit of it? I'm sorry, I don't feel like hooking up a fuzz. I've got some circuits here. I got they're all kind of connected to each other, so it would be a hassle for me to do that. But I'm sorry I don't have a test for it. The layout was from Aaron Nelson's gallery, so thanks to him. I think he's the guy credited for this. And yeah, we can take a look. My partner here is layout by Harold Sabro, based on a schematic by R.G. Keene. So Harold Sabro has his own little DIY collection of Vero layouts. He knows what he's doing. He's a great guy. I don't think he has a YouTube presence that I know of. But yeah, this was a fun little project. And apart from one, it didn't fire up. There was a ball of solder in between 2 of the rows, and I had shut my my iron station off. So I turned it on. And I kept picking at it. Once I got that cleared out of there, beep, we were in heaven. And I tried, like I said, I changed the value of R5. I tried swapping it out. I couldn't hear any. I mean, ideally, I think if I would do any mods on this, it would be to adjust the pitch. So I don't always have to hear the same tone. But that's my only nitpick. All right, I hope you guys enjoyed it. Keep in mind, this is the type of stuff that I do on an off day. I built much more complicated stuff than this. That's not to be, so complicated. But I'm just saying, I seem to find myself as a target more often than not. I don't want to say that. Most people are really cool about what I do, and they say, "Oh, you did a good job. It's entertaining. We like this kind of content." But I just feel like at the other turn of the screw, people are like, "Oh, that's the guy that builds all these little modular contraptions to connect them all together." Is it that way? Is it that way? Because I mean, I built this. I built plenty of amps. This is just all in one. So